Hello, guys. Here we are at episode 15, coding session trading signals. We are working on the trading signals project that will allow to connect um, trading bots to a bot that is emitting signal. So, in the last episode, we end up here at the point that the bot receiving the signals was executing the open stage, placing the orders. All good, except for when it has to close the stage. The close stage, this is showing that the order was not cancelled as expected, and it was filled right here. Okay, so let's check out the code again. We will be using this task server 1. Okay, and here I will not need this for now. Okay, so the cancel order event that was not triggered. We should try to figure out what was going on. Cancel order event. Check cancel order event. There is a function for that. And here we are. We also had a breakpoint for this. Enable breakpoint. Because we had the same problem before. So so the problem we are having now is specifically here. Why? Probably we need to close this stuff. Because the problem is just here. This is the cancel order event that is not being activated. So when we have a limit sell order, we are going to stop here. Okay, we get the signals, we will eval the conditions, and we will see what happens. So let's run this guy. Also, I will put a shortcut here. Control Alt Q. So that takes me here. And I will put a shortcut here. Control Alt W. Okay. Control Q, W, Q, W, Q, W. That is going to make me go faster. So I can debug this guy and I can run this guy. So the problem is happening probably 20-30 candles away. So we don't need to wait for this guy to run all through the day. With 20-30 candles, we are going to launch this bot. Enough, okay. And wait it to hit our breakpoint. Uh, okay, this is not the breakpoint we were waiting for. This is the breakpoint we were waiting for. Um, so how do we know? Because the order is a limited order, and we're going to get the signals here. Booms. We get 0 signal, which is not good. It is not good. Okay, we'll let it run again. We are at the same place, profit 06. So now we're going to see why we get 0 signals. Oops, we jump here. Okay, are we good? Create order event. There's something wrong here. We were supposed to be at the cancel order event. Check cancel order event. Oh, we are sending the wrong guy. Cancel order event. Okay. Okay, maybe that's the problem. Anyway, we are going to run the test again. We're going to stop this guy. Okay. What is this saying? So we're going to run this again. And we are going to debug this other guy because he's already running. Okay, it connects to the network node. That's cool. And now we're going to run this guy. And once it gets to candle number 50 is enough for us. It got stuck with the previous run, it seems. Okay. Okay, run the session. Perfect. So cancel signals. Oh, again, 0. Cancel order event. Well, maybe there was no, yeah, maybe it is okay. There is no, because it canceled the order every 2 candles. So maybe the next one we get a signal. Yep, we get the signal. So here, yes, and it's going to cancel the signal. Okay, so I'm not going to run this through the 1,000 candles because it's very, very slow and probably will not make it till the end. There is something that is not okay on running this too long. I don't know what the problem is. But what we are going to do is to run this guy again, both of them directly on at Node.js. So they will freely run all the way through the whole back test until the end. Let's see if it's ready to run. Yes. And this one should be ready to run. Yes. Okay. Now we will run this one, but we will let it run because the mechanism for keep them totally sync is still not there. I was thinking about this a little bit, and probably what we were going to implement is a mechanism by which, if we realize that we need to get synchronized here, then we're going to call this get all signals. And if signals maybe we will sleep here for a second and then try it again and keep it in a loop until I get the signal, because I don't really see the need. Maybe I can take it out of the loop if the session is stopped, for instance. That I think that at some point we are checking if the session is stopped. Here, for instance, we're going to stop here because we were requested to stop processing this session. Well, another possibility is to break the loop in a way, because if I keep it in a loop and only take it out when the session stop, I will have the problem that we saw in the previous episode, that by breaking the loop, the output files are not recorded well and the data is lost. So I don't want that to happen. So it looks like anyway I have to figure out how to break the loop without loss of information, of the previous information. For that, I will need to analyze exactly what is going on in this loop and to check what is What is what we need to do? It looks like we need to close the episode if we are leaving, for instance. Maybe the close episode function does something relevant. Update update exit type of the episode. Yeah, but the episode is not ending, in fact. That's not the problem. Okay, I will come back here. First, we're going to check this run. Okay, this guy already ran and processed all the candles. Good. So we're going to run the second bot, the one following the signals. Yes. Okay, both bot ran. Beautiful. I like it. It looks beautiful. It's really looking like everything went well. Yeah. It's very much looking like everything went well. Amazing. So this is the bot following the signals. So we will move this one with shift. We'll put it side by side. Also with shift, we are going to move the screen here. Shift Alt A. Well, I just want to know that everything is good. Oh my god, this is taking me the border. But I pretty much believe everything is good. There are some problems with this stuff. Okay. Why is this appearing? It's getting in conflict with the other guy on the top. Somebody please fix this bug. Okay, so this looks pretty much the same. 1, 2, 3, 4, 5, 7. Yes, it looks the same. So I would say this worked perfectly well, and that we are successfully synchronizing all the events tested in this strategy. There are pretty much not all of them, but most of them. So we will record a commit now. Synchronization of signals working well. Okay. This is beautiful. A bot using the signals provided by the other bot. Is perfect. Okay, let's go to the next problem. That is probably one of the last problems here to solve. That is, how do we avoid one having to run one bot and the other later? Okay. The problem we were having is that if the second bot catches up and um catches up with the first one, then it will break the loop, because we are saying break the loop, and then it's going to save all the information it has, and it's going to run again later, and it's going to catch up again and break the loop. But while doing so, what we notice is that it's not recording, at least it's not recording well, the information collected so far. Okay, that's the problem we saw. So it can continue doing it like this. I wouldn't mind if it recorded well the information. So I'm going to analyze why it's not recording the information. Okay, so I will follow the code inside the loop. That is not that much. It's up to here. Because the loop finishes here. Okay. So what makes this work naturally when the loop finishes naturally? That it doesn't make it work well when I break the loop here. That's the question. So let's see. Heartbeat, no relationship. Opening the episode if needed. Data structures. Position the candle. Update the chart object. Maintain. I'm wondering why here we are using this long version of the module and not the trading engine module. I know I am sidetracking now, but I'm pretty sure there is a trading engine module. Trading engine module? No, there is not. Okay. So let's continue. run the first cycle. We ran 2 cycles per candle. Check if we need to stop between cycles. And check if we need to stop after cycles. What is this? If we need to stop between cycles, then we have a break loop equals true, and we log some information, and break loop equals true. There are many reasons to break between cycles, and there is one reason to break after both cycles, that is, check next candle, which is a function that should be over here. We need to check that the next candle we have in just process is not the last candle. The last candle is the head of the market, trading engine, blah blah blah. Okay. So we have to pay attention to this because here some stuff happens. Checks next candle. So it seems that the loop really never ends by itself, but it gets broken always before the head of the market, before the end. That means before the last candle. Mhm. So the new stuff that happens is appended to the records. That means the output records. Here too, there is a run cycle. And this is the call to the next layer, the trading system. Okay, which is this one, and then it runs this one and this one and this. Okay. I didn't realize by checking this what could be the cause if I break the cycle earlier. What would be the reason? To not save the stuff correctly. Here we have the question, if break loop equals true, then breaks. Okay. So if it can break the loop here, after it append records, or it can break it here, and everything works well, why it cannot break it here? Okay, I'm going to debug this because I cannot see which could be the difference. I really cannot see it. Whatever. Okay, so we are going to run this guy. We are going to run this task. And we are going to debug this task. And we're going to run this guy. And very shortly after, we're going to run this guy. But we need to put a breakpoint. Yes, and we have it. So we're going to run this guy. So let's go. Oh. Well, I really didn't need you to stop here. But now this guy is very slow. He's never going to catch up. Okay. For some reason, this didn't find a signal here, which is a little bit strange. Maybe something happened when this enter into debug mode. The signal doesn't arrive. But whatever reason, we are in the situation in which we are going to be exiting the cycle. Something is not very stable because this disappears unless it appears somewhere here. I don't know where where the execution is now. Something is not good. It's simply not good. Not responding. What about luck? I think we will have to do it again. It will be useful in this case to delete the information of the trading bots because I want to see what gets recorded and what not. So I will run this guy. I will run this guy. Debug here. Okay, both are running. I'm going to run this one and the other guy too. Come on. Now the other is coming much faster. Can you believe that? I see something not very good here. That we're calling this function without an await, these write files. And these write output files. So we are awaiting these write files. Okay. We are awaiting this. Okay, so this write files is a function we receive by parameter. Okay, cool. So we are awaiting this write files, and when we receive this run simulation from this same module, write files is this function. Okay, but here output management functions write files. So we're going to enter this function but without an await, which is not really a good idea. Okay, now we are here. Output management functions, which is an async function. Okay, call from here. Without an await. And this output management functions is going to, where are we? going to enter in here. Which eventually is going to enter in here. Write output file. With an await. And the output file is going to make an await here. And here it returns a promise. And here the stuff gets lost, who knows where. So we're going to fix this. Maybe this helps because this was not awaited. Okay, so I'm going to go back here, stop this, we stop this. I'm going to delete this again, and I will run both of them directly in Node.js so that this one can go faster and do the break loop. I am not really believing that that was the problem, but who knows. So we're going to run this guy. Oops, I deleted something. Not good. I'm going to refresh this so that I get this back. Okay, let's do a little bit of a recap. In the first part of the episode, we fixed the latest bugs that preventing the bot following signals to be fully synchronized with the bot sending the signals. After that, we are trying to avoid the problem in which the bot following the signals go faster than the one emitting the signal, and when it waits for it, then it doesn't record the information well. So we will let it run to see what is going on, because that test was several episodes back and many things have changed so far. So what I'm going to do now is to make sure this is not running. The last await was not at the async function. Okay. That's the reason why it didn't start. Okay. So now it should start. This doesn't have any data. And now this guy should start. Okay, we will just let it run. This guy runs, and this guy runs. This one started. It's going pretty fast. Okay, but now this catch it up. It's waiting, catch it up. Waiting again. And it stops. Okay. So let's see what the chart of the guy that stopped looks like. You see there are no orders. So it looks like the information was not saved. Okay. What I'm going to do, right? This guy, until it doesn't finish, is not going to record anything here. Because the saving is done when the loop finish. The first day, at least. Okay, well, what we are going to do here is I don't need this, I don't need this. No functions. I will put this guy here and this guy here. And what I'm going to do is that I'm not going to leave the loop to break the loop. So we're not going to have that problem. And just if the signal is not there, we're going to wait for it. Just wait. So how do we do that? Here. The first thing I will need is a sleep function. That I understand that we have one somewhere. Mhm. Um, okay, this is what I'm looking for. What I cannot understand is why I cannot get any example of anyone executing this function. it seems that nobody's using it. I guess this is wrong also. It should be an async function. And how are we going to know where this is? Okay, PL. That is platform. Okay. So the platform, in order to use this, I will have to move it. This is another pro tip. Okay, let's do this. I want to use a function that was defined as an utility for the platform. But now I am at the task server. So I cannot use it because I have access to all the modules defined for task server and for superalgos, because as I am running the task server, naturally I have access to this. And superalgos is a common set of modules that are available to any of the applications, task server, platform, desktop, or whatever. So I will need to move this into here. This utility, async functions, into here. So that is exactly what I'm going to do. Move it here. Okay. I haven't found anyone using this sleep function because I made a search by .sleep and absolutely nothing was coming out from there. Yes, there is some sleep wait time, but it's not the same stuff we are talking about. Okay? Otherwise, I would have to refactor those calls. But since there is none, it seems that somebody was using it and then it was deleted, and the usage but not the function. So as I'm going to use this, I will need to correct the profile schema file, which we can find in the project schema file. Okay, hold on. Async function. There, I will put this guy here. So the project schema, we're going to load it. Oh my god. In training, project schema. Async functions. Let's search for that. Async func. Okay, so this is declared inside platform, but we will need it inside SA of the same project. Okay, cool. Now, how are we going to call this guy? Well, in a similar way that somebody's calling these guys. So, for instance, I'm going to get one example of this. Up to here. So at the trading simulation, I will have this. But instead of calling time constants, I will call async functions. And the function that I'm going to call is the sleep function, passing milliseconds. Okay. Async functions sleep. We sleep for one second. Okay, so I will have to await this because the sleep is going to make me wait here, and I'm sure this is an async function where we are. Yes. So yes, that's the way we move one module that was defined somewhere else to a common place that is SA, and then we use it like this. Okay, so then the logic to wait for this signal to appear. We will start putting everything inside a while. While true, this will loop forever. Okay, so we're going to get everything inside, and what is going to happen is that we're going to get the signals and get one individual signal, and if signals is undefined, else we will break the while loop. Okay, if signal is let's say if signal is undefined, this means that the signal we are waiting for has not yet arrived. So we are going to break the simulation loop. So we are going to wait for 1 second and check it again. And here we are put the wait stuff, and we are not going to break. Okay. Okay. So this is a while that is going to loop forever. And the only way to break it is to receive a signal. And when we receive a signal, we get out and continue. If we don't receive the signal, we are going to wait here for 1 second and try to get the signal again. And again and again and again. I understand this might not be perfect, but it should be working for now. The problem will happen one day when the bot sending the signal doesn't send the signals anymore, and this guy is going to be waiting forever, and there's not going to be really a way to get out of here. Okay, but we'll figure that out after we see if this is enough to make this work. Okay, let's check it out. We'll close this, we will delete this, so now I expect this to run side by side, with this going a little bit ahead and this catching up every 1 second. So it will wait for 1 second for this one to go ahead a little bit more, and then it will continue process. So let's try it. This will run now, and you can run. Not so fast. Okay. Foundation is a globals. Okay. I put it at the wrong place at the profile schema. Yeah, you're right. I put it at the wrong place. Sorry. It was meant to be, I believe, a utility. Yes, a utility together with miscellaneous and all these guys. Okay. Okay, no problem. Okay, oops, and now this got stuck. Oh my god. Oh, and on top of that, I forgot to switch the screen and I'm not showing what I'm doing. I don't remember when was the last time Okay, so I'm going to show, sorry for that. Um, I was working here at the profile schema file, putting this async function here, and I was coding the trading simulation, this little loop where it's going to loop forever, waiting for the signals, and when it is undefined, it's going to sleep for 1 second and continue in the loop. And it's only going to break the loop when it receives the signal, the synchronization signal. Okay. Okay. So let's continue. Here we go again. Run. Run. Okay, now it's running. Now you can run. And you can also run. So I expect the two numbers to go very close. This one a little bit ahead. Oops. Unexpected error. Okay, stop. Cannot read property of undefined reading sleep. Okay, because this is utilities, it's not global. UT. Okay. Again. Run. 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 12. Okay, something is wrong. Something is wrong because it's exiting the loop at candle 75 and I don't really know why. It's not only exiting the loop, but it's exiting everything. Hmm, maybe I know. Okay. Wow. When we when we let the first bot to run, it ran all over the whole day, finish, and we ran the second one, and it ran all over the whole day, finish, and everything went well. Why? What it could be happening is that now, when the bot catches up and gets to the other bot, maybe it finds the signal. It finds the signal of the candle execution, the synchronize the candle, but it doesn't find some of the signals of that candle. So because it doesn't find it, it enters into some different behavior that make it exit the loop or for whatever reason. So I believe that the problem is, in this case, that we are broadcasting this signal before executing this candle. So what we need to do is to execute the candle and then broadcast the signal that that candle and all the signals that belongs to that candle are already in place. So that when the other bot detects this candle and execute that candle, it also finds it also finds all the candles belong all the signal belonging to this candle. So this I'm going to move it towards the end. But I have to be careful because there are many places where I could be exiting the loop. And I don't want to exit the loop without sending the signal. Okay? Yeah, I don't want to do that. I don't want that to happen. So, which would be the place to send the signal? Run cycle. Hmm. Okay, here I can break the loop, and here I can break the loop. But if I don't break the loop, here the loop ends. So there's nothing else. So it looks like we will need a function for this that we can call after everything has been executed, and it's going to make the next round of the loop, but not really, because if I do it after everything executed, maybe I'm moving some counters or whatever to the next candle. So I need to do it. Okay, more or less. There's also another problem, and the problem is that we need different cycles. So maybe I need to send this signal for each cycle, cycle 1 or cycle 2, and not for candles. Hmm. I wouldn't like to send two signals per candle, but at the same time, okay, my question is, does these checks modify something, or are these only checks? Update episode. This can update the episode, Jake. So probably we run the first cycle, we run the second cycle, and we call this stuff. Outgoing episode synchronization signal send end of both cycles. Okay, so we will broadcast this after we run the second cycle and before we do this check that we know that might change something on the state of the trading engine or whoever. Okay, so this is one place that we are going to send it. And also, if after the first cycle we understand that we need to break the loop, we are going to break the loop, but we are going to send also outgoing episode synchronization signals sent before breaking the loop. Okay, so this might work better. Let's try it out. We will delete all the information there. We will run this guy and also run this guy. So now we can run this guy and also run this guy. Okay, it's working as expected so far. Let's see if it goes through the 70 candle. Yep, it's going. Wow, this time it might work. Yep. It looks like it's going to work. I can put the sleep to wait for less and it would go more fluently, but I don't know if that matters or not. It looks like half a second is enough to send a few candles of signals anyway, so probably half a second would be more fluent. Okay, so if this works well, I will have to think what comes next because I don't recall any other problem. For this mechanism per se. I know that the node, the network node is broadcasting the signal to every WebSocket client connected. Doesn't matter if it is following this social trading bot or not. So there's some work to do there. Um, but don't know if that is the next thing to invest time in. I will have to think about it. Okay, almost finishing. I hope that when bot number one finishes, the second one also finishes, exiting the loop naturally and doesn't get stuck there. It should. I I believe it should. Come on. Yeah, perfect. Perfect synchronization. This looks perfect, man. They're exactly the same. Beautiful. Beautiful. Fully synchronized. Amazing. So essentially, this is like a historic moment. The first bot fully synchronized. I'm going to, before I forget, I'm going to make the last change I wanted to do. That was about um, we're going to wait only half a second. We are going to commit this. commit. Okay. Episode synchronization working well. Okay, good. So before I close the episode, what I'm going to do is to merge to contribute this code to develop, because we are already testing lightning strike, and lightning strike even with signals everything is working. So I'm going to move here. Wait, before that I'm going to save. Then I'm going to move to a workspace I use for contributions, where I have my ID, my GitHub token, sorry. Um, okay. Um, so for the first time, we managed to make this fully synchronized bot. That means that we could run a network node at some place on the internet, and from home we can broadcast signals through that node to any number of bots connected to it, and they will all execute the lightning strike strategy backtest at the same time. And that is pretty much a big deal, because it's the first step on creating an army of bots from multiple people, or with multiple people, over a peer-to-peer network that now is one node, but next steps are going to be working on the network to making sure that we can broadcast, we can move the signals through the node, so that anybody connected at any node can receive it and run their bot fully synchronized with the one emitting the signals. Okay, so it is beautiful. So to finalize, we're going to do an up contribute, and probably this is going to be the last episode of trading signals, because I will be moving probably to work on either on the network or on something else, because I am already satisfied with this, with the current achievement. I don't see me spending more time right now on this, so this is like enough until some people start testing it. But I don't see anything to get really deeper on this. So that this might be the last episode for now of um, trading signals. Okay, so I'm going to contribute the trading signals, trading project MVP working. This is like the minimum viable product. So contributed, and that's it. That was today's episode. Thank you for watching. Hope to see you again at the next one of this series of trading signal, or whatever series come next. Thank you.